Hello everyone, in this video, we present our paper, Towards Artistic Image Aesthetics Assessment, a large-scale dataset and a new method. Most of the current studies on image aesthetics assessment are restricted to real-world photography images. Little light has been shed on measuring the aesthetics quality of artistic images, and the existing datasets only contain relatively few artworks. To fill the gap, we first introduce a large-scale AIAA dataset, Boldbrush Artistic Image Dataset, BADE, which consists of 60,337 artworks. We then propose a new method, Style-Specific Art Assessment Network, SAAN, which can effectively extract and utilize style-specific and generic aesthetic information to evaluate artistic images. Experiments show that SAAN outperforms the SOTA-IAA methods on BADE. The task of Artistic Image Aesthetics Assessment, AIAA, requires automatically evaluating the aesthetics score of an artwork, which is similar to IAA for being extremely challenging due to its highly subjective nature. However, existing public AIAA datasets, such as GenAesthetics and VAPS, are not large enough to meet the requirements of deep learning methods. AIAA methods have not been adequately studied. To solve the problem, we introduce a large-scale dataset specifically constructed for the AIAA task, the Boldbrush Artistic Image Dataset, BADE, which consists of 60,337 artworks annotated with more than 360,000 user votes. The proposed BADE is by far the largest AIAA dataset, which far exceeds existing IAA and AIAA datasets in the quantity and quality of artworks. We use the Boldbrush website as the source of data. Boldbrush hosts a monthly artwork contest where certified artists can upload their works and receive public votes from online users. We collect contest entries created by numerous artists starting from July 2010 to June 2022. Unlike the existing IAA datasets where the score distribution is used to calculate the mean opinion score, we directly convert the number of votes to the scores of images in BADE. We adopt the average number of votes of the month as a varying criteria and a sigmoid-like function to generate the scores. The generation of the score annotations in BADE is based on votes, which makes it hard to filter out unreasonable labels. To eliminate the concern about bias, we calculate the most frequently used painting medium and the average scores of the artworks created using the specific medium in BADE. Furthermore, we calculate several handcrafted features and measure their correlation with the scores of the artworks. We randomly select 6,400 images from BADE and the results are shown in the tables. The results indicate that our dataset suffers little from art preference bias and is of high credibility. Furthermore, we propose a baseline model, called the Style-Specific Art Assessment Network, SAAN, which can effectively exploit the style features and the generic aesthetic features of the given artwork. Our model consists of three modules: Generic Aesthetic Branch, Style-Specific Aesthetic Branch and the Spatial Information Fusion module. Observing that the style of the artwork is critical when assessing its aesthetic value and different styles need to extract different style-related aesthetic features, we propose the Style-Specific Aesthetic Branch to incorporate style information into aesthetic features and extract style-specific aesthetic features via adaptive instance normalization. The output produced by a DANE will have the same high average activation for the specific style feature, while preserving the spatial structure of the image. To the best of our knowledge, none of the existing IAA methods has considered the integration of style information into the prediction model, and we are the first to combine style information with the assessment process. The Generic Aesthetic Branch extracts the aesthetic features shared by common categories of artworks. Inspired by recent studies, we adopt a self-supervised learning scheme to train the backbone to extract aesthetics-aware features. The self-supervised scheme is based on the correlation between the aesthetic quality of the images and degradation editing operations. This essentially provides data augmentation such that the model can better learn the quality of different artworks. In the Spatial Information Fusion module, we add a non-local block before the multi-layer perception to fuse the spatial information and implicitly detect the composition of the artwork. ImageNet pre-trained backbones are not well suited to the AIAA task. For instance, such classification model should be invariant to the image's brightness and thus prohibits taking the image's brightness into account when evaluating its aesthetics. Inspired by related works, we adopt a self-supervised pre-training approach in our work, which includes two aesthetics-aware pretext tasks. One to identify the type of the distortion applied to a given image, and the other to detect the intensity of the applied distortion. For each image in BADE, we randomly choose 3 manipulation operations in the table shown to edit it. We make 2 improvements to the operations and the parameters. First, we add operations that distort the layout and the composition of the original image, for example, cropping and convex. Second, we add art-related distortions, for example, the stylization operation will generate unwanted lines given a fine artwork. We visualize the results produced by our newly added distortion operations. We compare our method with 5 state-of-the-art open-source IAA methods on our BADE dataset, including NEMA, MPATA, MLSP, BIAA and TANet. We retrain these methods on BADE using the recommended parameters in the original paper. We adopt 3 metrics for evaluation: Spearman's rank correlation coefficient, SRCC, Pearson correlation coefficient, PCC, and a threshold of 5 to calculate the binary accuracy. Compared with these methods, our model achieves the best performance on all metrics. This suggests that understanding the style of the artistic image assists in perceiving the aesthetics of the image. To better validate the proposed style-specific aesthetics branch, given an artwork, we randomly select several images with different styles from BADE, make them the input of the style feature extractor and compare the predicted aesthetics scores. When the style feature is extracted from an artwork with a different style from the original input, the predicted aesthetic score will decrease and the prediction error will increase, which further validates our idea of utilizing style information in AIAA. In conclusion, we address the challenging task of artistic image aesthetics assessment. To achieve this goal, we create a large-scale dataset BADE, which is constructed completely from artworks. We further set up a complete benchmark and develop a baseline model called SAAN, which achieves state-of-the-art performance on BADE. We hope our contributions will motivate the community to rethink AIAA and stimulate research with a broader perspective. More details of our work can be found in the paper.